Hello everyone. Welcome to this video on learning mathematics through concepts and examples. Here we are going to learn how to sketch graph of the function using properties. So let's take an example. So here we have the example. We have to sketch a possible graph of the function f of x that satisfies this condition. So in the first one, you can see they have given where the first derivative is positive or where it is negative. In the second property, they have given where the second derivative is positive and where is second derivative negative. And in the third one, they have given limits at infinity or the end behavior. So let's first look at this third property. So as x approaches to infinity, so I'm going to make use of that property first. So when x approaches to infinity, you can see that the function value is 2. So meaning of that is when the value of x is large, okay, when the value of x is large, look at the mouse here. When the value of x is large and it approaches towards infinity, okay, towards infinity, what happened is the function value goes to 2. So that is the horizontal asymptote on this side is y equal to 2. So we can draw the horizontal asymptote like this. That is y equal to 2. Y is equal to 2. Similarly, when x approaches to negative infinity, so when x becomes very, very small, when it goes towards negative infinity, the value of the function approaches -3, or the horizontal asymptote is y equal to -3. So we can also draw that. So that is the horizontal asymptote y equal to -3. Okay, so we use this third one. Now let's use the derivative. So if we look at the first derivative here, the first derivative is positive from negative infinity up to 2. So from negative infinity up to 2 here, up to -2, right? Negative infinity up to -2, the function is increasing because the second derivative is positive. And then from -2 up to infinity, first derivative is negative, meaning the function is decreasing. So I'm going to draw a vertical line at x equal to -2. I'm going to remove that line at the end, but just to show that on this side, the function is, you can see that on the left side of that x equal to -2, first derivative is positive, meaning the function is increasing here. And on the other side, from -2 up to infinity, right? The first derivative is negative, so the function is decreasing on this side. So that is our -2. That is -2. Okay, so note that on the left of this vertical line, the function is increasing. That means it is going upward. And then after that, the function is going downward. So remember, this side, the function is going upward, and this is the asymptote. This side, the function is going downward, and that is the asymptote. Now, so we use the third property, we use the first property. Now let's use the second property and then start sketching the graph. So what is given here is the second derivative is greater than 0, meaning the function is concave up from negative infinity up to -5. So here is negative infinity, here is -5. Up to there, the function is increasing, we know from the first, and it is greater than 0 means it is also concave up. So the possible sketch might look like this. So I'm going to select that point and then draw the graph like that. And you can see that this graph is concave up. And also if we go from left to right, we see that it is going upward. Okay, so the second derivative is greater than 0 on that interval. And also it is greater than 0 on this interval from 4 up to infinity. Okay, let me label 4 on this axis. So 4 is here. So that is x equal to 4. So you can see that from 4 up to infinity over here, okay, second derivative is positive. So here, second derivative is positive, 4 up to infinity. We already know that the graph will be increasing and then coming down. That's what we already know. It is decreasing here and also it has to be concave up. So I can select any point somewhere here. Okay, any point somewhere there. Maybe I'm going to select that point. And then because it is a sketch, so you're free to select any point and draw the graph that is concave upward. See, concave upward, it is also decreasing here because it has to decrease. And this line is the asymptote. We got that. Okay, now that is this part. Second derivative is greater than, that means the graph is concave up from negative infinity up to -5 and 4 up to infinity. Now the next thing we have is second derivative is negative from -5 up to 4. So in between from here to here, second derivative is negative, meaning the graph is concave down. But what we know is this graph is increasing all the way up to this line and then it is start decreasing. So you can select some point on this line. It's up to you what you want to select because it is just a sketch like that. And then we have to draw the increasing graph here with concave down. So meaning your graph will look something like that. See, it is increasing and also concave down. And this side, now it has to decrease and concave down. So decrease and concave down. Like that. So that is a possible sketch. I'm going to remove that vertical line now. So let me remove that vertical line. Okay. Let's see, it's not letting me remove somehow. Okay, probably I'll be able to remove. So that line is gone. Also, I'm going to erase this increasing and decreasing. But I'm going to add some important properties here in this graph. I mean, important point on this graph. So you can see here, if we start from this endpoint, from here to here, the graph is concave up and then the graph is concave down. So concavity changes here. So the point at which the concavity changes, that point is the inflection point. So that is inflection point. That is inflection point. Also, you can see that if we go from this end of the graph all the way up to here, the function is increasing. And after that, function is started decreasing. So the function goes from increasing to decreasing. So the concave, the nature of the graph changes here. So right here, this point is the critical point. Okay, the point where the graph was first increasing and all of a sudden it starts decreasing. So that point is the critical point. So that is critical point. Critical point is the point where the graph changes the first derivative sign, increasing to decreasing or decreasing to increasing. And after that, here the graph is going down all the way up to there. But what happened is from here to here, the graph is concave down. And after that, the graph is concave up. So this point is also the inflection point. Okay, that is the inflection point. So this is how you can sketch the graph of the function when the property of the function are given. So we can use the properties and we can sketch the graph. You need a little bit of practice on problem like this, but you'll be totally fine on this. It is not that difficult. Okay, that's all in this video. I hope the video was helpful. Thank you so much for watching.